Today we're going to be going over quadratic graphs. Now these are worth about 20 points on the average SAT. Our approach to these is going to be to identify quadratic graphs questions. We're going to break down the question. We're going to build a formula to solve quadratic graphs questions, and then we're going to solve a practice question together. So how do you identify these? Well, these questions will give you the graph of a quadratic, or they're going to describe the quadratic, and they'll describe it kind of graphically. So they'll ask about some aspect of a graph, and they're going to ask you to find something like the maximum or minimum, or they might ask you to find the roots/zeros. So here's our quadratic graphs formula. First, we're going to understand what we're looking for. Second, we're going to look at our graph. And then third, we're going to find this answer depending on our graph. So here's an example problem. It says f of x equals 2x squared minus 16x plus 50. The function h is defined by h of x equals f of x plus 10. For what value of x does h of x reach its minimum? So let's understand what we're looking for. Well, we're looking for what value of x does h of x reach its minimum. Now we're going to step number 2, and we're going to look at our graph. Well, this one, we don't have a graph, but it's describing a graph to us, and this is the graph it's describing. It's asking about a graphical feature, the minimum, which is what I was meaning when I was saying that it might ask about a graph. So a good thing to know for the minimum is that the minimum of a graph, the x value, is going to equal negative b over 2a. Now this is just a formula you're going to have to memorize, and it's going to be one that they won't give you on the test, and so just memorize that minimum or maximum of a quadratic is going to be negative b over 2 times a. And in terms of a and b, our quadratic is set up in this way: ax squared plus bx plus c. So a is going to be the term in front of our x squared, b is going to be the thing in front of the term x, and then c is going to be the value with no x next to it. So for our example, we have negative b, and we have a negative 16 over here, so x equals negative 16 over 2 times a. A is the 2 in front of here, so 2 times 2. This is going to give us 16 over 4, or 4. Now don't be tricked here and think that C, our answer 4 here, is correct, because we just found what x value is going to reach its minimum at for our normal graph, f of x, but not this h of x, which is what it's actually asking about. So to understand this, we need to review our translations quickly. So if we have a graph f of x plus 10, if it's inside the parentheses, this is going to shift us left 10. Left 10. And if it would have been minus 10, it would have shifted us right 10. Now if we have f of x plus 10, this is shifting us up 10. And if it would have been f of x minus 10 outside the parentheses, it would have shifted us down 10. So for this one, we saw that it shifts us left 10. And so if we had negative 4, we need to shift this negative 4 left 10. So our f of x would have been at 4, but our h of x is shifted left 10, is going to be negative 6. And so negative 6 is our answer. A, don't get tricked by C. It's a common way they get students. Now, hopefully all this math we did made sense, but if you got to this problem and didn't remember the formula maybe, or you're just getting stuck, this one is a great one to use Desmos for. So as you can see here in Desmos, I plotted our first equation given, our f of x, you can see it here in blue, and then I also typed in f of x plus 10, exactly how it showed it to us, and Desmos understands what this means and graphed this green quadratic for us. So if I click where it looks like the bottom of the graph is, or the minimum, for the blue one, I can see it is 4, just like we found, and for the green one, I can see it's negative 6, like we found. So Desmos is super powerful on these. It's going to help you make sure you get the right answer, and it's probably going to be quicker than the way that we just did it, and so make sure to use Desmos to either solve the problem itself or to at least check it like we did. It's a super powerful tool. So we talked about some good Desmos shortcuts. Good luck on this concept.